Hello everyone. In this video, we are going to discuss about the concept of probability. Probability, B-I-L-I-T-Y. Probability. The thing probability is actually kind of a percentage. Percentage. It gives a percent of happening a chance of to the not happening chance. It gives a percentage of some sort of thing is happening, which will happens or which will not happens, won't happen. It gives a percentage of whether it is happening happens or it will not happen. It gives a percentage in terms of chances, more likely to say the chance of winning or chance of losing it will indicates. So in this concept, probability concept, we have to define two things. In this concept, we are going to discuss two concepts in order to consider the probability. One is favorable events and another one is total events. So what is meant by favorable events? Say suppose you're flipping a coin. Take an example of flipping a coin. Flipping a coin. Say suppose in a coin we have actually two places. One is head and another one is tails. So this is known as sample space. Sample space. There is no such thing for the coin to change its position from head to tail. Apart from these two entities or events, there is no other event will be occurred. We call these two things as events. We call two things. Head is a one event and tail is another events. There is no another thing to occur when we flip a coin. So suppose if I want to know the percentage of getting the head. So for the head, so we have to consider the number of events. How many number of events in this sample space such that there is a head at least. So if we write S equals to sample space equals to H head and tails, there are only two events. So N of S is equals to 2. This is total events. N of S equals to 2. There are only two possible outcomes by flipping a coin. But I am looking for head. How many heads are available here? Say suppose number of heads. There are only one in this sample space. So that means it will become 1. Now the definition of probability is probability of getting head equals to number of favorable events, the thing which you are looking for, to the total number of events which are in sample. The number of events which are what we are looking for the head. How many events are occurring, outcomes are we are getting only one, and the how many outcomes are there in the sample space 2. So that means probability of getting head is 1/2. And similarly we can find the probability for the tails also. So if we write the sample space for the for the tails, there is n of t equals to how many number of tails in this sample space? Only one. So then the what will becomes probability of getting tail? Similar concept. Probability of getting tail equals to number of favorable events to the total number of events in the sample space. How many number of events? 1. And how many number of sample space? 2. So that means probability of getting heads is 1 and probability of getting tails is probability of getting head is 1/2. That means 50%, and probability of getting tail is 1/2, which is 50%. If we add up together, it will becomes 100%. That means probability of getting head plus probability of getting tail is equals to 1 or 100%. We have to consider this formula. This is very important. Why? Because if we know the probability of head, we can find easily the probability of tail. If you know the probability of tail, you can find the probability of head. Let's see how it works. Say suppose we know that the probability of getting head is 1/2. If we substitute in here 1/2 plus probability of tail equals to 1. So what will becomes probability of tail equals to 1 minus probability of heads. So this is a formula from here. So what is the probability of head here? 1/2. Yeah, the plus sign will becomes minus sign if we will goes to right hand side. So then the probability of 10 becomes 1 minus 1/2 equals to 1/2. So that we can simply get the concept of probability with this concept. Example of the coins. For example, we have two coins. Okay, we have two coins. Say suppose if we flip the coins once at a time, what is the probability of getting same events? So what are the same events? We have to question ourselves that what will be the same events, isn't it? So the same events will be, we have two coins, one coin and another coin will have same events, same sample space. We will have head tail for the first coin, we will have head tail for the second coin also, but he is asking the same event. What is the same event? By flipping the coins, we have to get either head or either we have to get tail. This will be the same events. So we have to consider these conditions. Firstly, we have to list down the sample space first. In order to find this concept of same probability of same events concept, we have to list the sample space. So what will be the possibilities if we flip the coins? Say suppose maybe it will becomes heads and head tail and tail head and tail. Okay, there are four possible conditions for if we flip the coin if we flip the two coins. That means n of s, number of events in the sample space is 4. Okay, and the thing we already discussed that the same number of events are head and tail. How many events are present in this sample space of similar condition? We got only the 2, 1 and 2, because head and tail. So that means number of same events is equals to 2. Okay, then the probability of getting same event equals to number of same events by total number of sample space. So number of events, how many number of same events? 2, and number of sample space is 4. So that means it becomes 1/2, which is ultimately 50%. Okay. So now we know that the probability of getting the same events is 1/2. If we asked for the probability of not getting the same events, what will be the concept of? It's a simple concept. Just we have to apply this concept. Probability of getting tail equals to 1 minus probability of getting head. Here also probability of not getting the same event is equals to 1 minus probability of getting same event, isn't it? So that becomes 1 minus 1 by 2, which is equals to 1 by 2, which is equals to 1 by 2. So that indicates that probability of getting same events equals to 1 by 2, and the probability of not getting same events equals to 1 minus probability of getting same events. If we do the calculation, we will get the probability 1 by 2. And another concept which we have to consider is in the case of dice. In the case of dice, you know the dice, it comes with the 6 faces having the numbers of 1, 2, 3, 4, 5, 6, up to only 6 entities will be 6 numbers will be faced in the single die. So we can write the sample space for this will be S equals to 1, 2, 3, 4, 5, 6. There is no such thing beyond the 6 and less than the 1, isn't it? So the sample space, the number of sample space is equals to 6, isn't it? So suppose he asked to find the what is the probability of getting even number. If we roll, suppose if I roll a die, what is the probability of getting a even number? So in order to get the even number, what we have to do is, first we have to list down the entities such that we have to get the even numbers in the sample space. So even sample space becomes 1 is not an even number, 2 and 4 and 6. These 3 are even numbers. So what is the number of entities in the even number? It is n of even is equals to 3. And what is the probability formula? Probability of getting even equals to number of favorable events, which is in the case in even numbers, number of even numbers, so probability of getting the even number, and the total event will be n of s, or total sample space. So number of even numbers will be 3 and total number of sample space is 6. It becomes 1 by 2. And if the question is asked like that, to suppose I need to find the probability of getting odd number, we can do directly by substituting the concept of probability of even is equals to probability of getting the odd numbers is equals to 1 minus probability of getting even number. So that means 1 minus 1 by 2, which becomes 1 by 2. Probability of getting odd number is also 1 by 2. Or else we can write the sample space for the this concept of die ruling. We have to list down the elements 1, 3, 5, and we have to note down the numbers. How many numbers are there? 3. So then we can write the formula for that, for the concept of odd numbers. Probability of getting odd number equals to probability of number of odd numbers by total number of events, n of s. So that it becomes 3 by 6, which is equals to 1 by 2. Both the answers will be relies upon same value, but this is a time consuming process if we know the probability of even number. Okay, another concept is, in the concept of die, what is the probability of getting prime number? What is the probability of getting prime number? So if we ask to find the prime number, we have to list out the entities. You know the concept of prime numbers, which is the number which is divisible by 1, and the number itself is known as prime number. The prime numbers in the die roll will be 2, 3 and 5. There are only 3 numbers for the dice, for the die concept. So the number of prime numbers 1, 3 and 5. 2, 3 and 5. These are the prime numbers. So we can directly write the probability of getting prime number, which is equals to number of favorable events by total events. We know the how many numbers of events which we are looking, 3 events. So that means it becomes 3 by 6, which is ultimately 1 by 2. So right now we know the probability of getting prime number. What is the probability of getting not a prime number? Not prime. It becomes 1 minus probability of getting prime. So that means it becomes 1 minus probability of getting is 1 by 2. That becomes 1 by 2. 1 minus 1 by 2 equals to 1 by 2. Say suppose there are 2 dice. So what will be the sample space? We have each single die has 6 sides. Another die also has 6 dice, 6 sides. So ultimately total possibilities of getting events will be 36. Total number of events, if we roll the 2 dice, will be 36. What are they? We can write those numbers as 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Like that, we have 2, 1, 3, 1, and 4, 1, and 5, 1, and 6, 1. Sorry, 5, 1, 6, 1. Like that, we'll reach up to 6, 6. So total will be 36. In this 36, if the candidate is asked to find the sum of two numbers which is greater than 10 or 12 or something like that, we have to list down total sample space in order to do that. So I am trying to eliminate the concept of writing down the sample space. So what is the logic here is, if we ask to find the sum is which is greater than or equals to 10, greater than or equals to 10. Say suppose we know that the number which is near to in order to get the 10, we only know that there is the combination of 4 and 6 will give the value of 10, and if we reverse the concept, we will get 6, 4. That means there are two entities, and what happens, what the next entity will be, we can increase the one value and decrease another value. We will get the third possible outcome. If we increase the one value, 4 becomes 5, and if we decrease the other value, it becomes 5. So these only 3 conditions which satisfies that the sample space which is exactly equals to 10, which is not greater than or equals to 10, which is exactly equals to 10. Suppose if we asked to find the sample space which is greater than 10, first we have to write the events which will equals to 10, and then we have to focus on the entities which are greater than 10. So that means it becomes just we use as usually, increase one number and decrease another number. You will get 5 as you increase this number you will get 6, as you decrease you will get 4. So that means there is no possible outcome for this thing. We can increase the number by adding 1 to this entity, that becomes 11. If we reverse this possible event, it becomes 6, 5. Like that we can deduce the things which by not writing the sample space. Say suppose he asked to find the what is the possible condition of getting the sum of the number which is equals to 8. So ultimately take an example, can we get 8 with 1, 5? No. So we have to increase the numbers. If we increase the numbers, we will get the sample space for the 8. If we increase 2 and 5, it will becomes 2 comma 6. 2 plus 6 will becomes 8. So that is one entity. And if you reverse it, you will get second event, and you increase the first value and decrease the second value, increase the first value and decrease the second value, you will get the second possible event. And if you reverse this concept, you will get another possible event, and do the same thing until you get the equal position or not satisfying position. Up to 4 comma 4 you will get the numbers like sum of numbers will become 8. If we go further, 3 comma 5, will it gives the value of 8? Yes, it will gives, but it is also sorry, I mistakenly write here that it's not 3, it's 3. This entity is already here, so we need not to take this one. Just count the events 1 2 3 4 5. There are 5 possible events. To counteract the situation that the number of equal events for satisfying the condition 8 will be 5. Like that we can do the concept until we get the equal position or not satisfying the position or repeated number.